Okay, so what we're going to be looking at is we're going to be looking at quadratics and quadratic functions and some of the stuff that goes along with it. And so what we're going to start with is when you have a quadratic function, you end up getting something that looks like a parabola, like here the arch in St. Louis. Or when you throw something in the air, it follows in a parabola shape. Other things that look like parabolas or have that parabola shape, if you look at it like a flashlight, and where the mirror on the inside, so all the light is forced out in one direction, if you were to cut that in half, it would make a parabola shape. Okay. Other ones, a satellite dish also does. If you cut it in half, it's, if you take it two-dimensional, you get this nice parabola shape, or this like arc looking. And so for your quadratic terms and parabolas and all this, usually it will be written in standard form. And for standard form, it will be f of x is equal to ax squared plus bx plus c. The part that is attached to the x squared, okay, the part that's attached to the x squared is called the quadratic term. And so the part that's added to the part that has just an x is called the linear term. And the constant term is the part that does not have a variable attached to it. So if we look here at this one that I just wrote on the bottom, your quadratic would be 4x squared. All right. Your linear would be negative 4x, and your constant would be the 8. Okay. And so the part that's attached to the x squared is your quadratic term. The part that's attached just to the x is your linear, and the part that does not have a variable is called your constant term. And what we're going to be looking at is we're going to be looking at functions that have x squared. Okay, and that's what gives us the nice little shape. So if we look at these are three different functions, and they've got different names for them. The first one would be called a quadratic function. Okay, it is a quadratic. You see how it's x squared. Okay, the next one, since it's not an x squared, it's just x, that would be linear. Okay, so that would be a linear function. And the last one doesn't have a variable. That is called a constant. Okay, which means there is no change, and it's just a constant number. All right. So if we want to be able to identify, okay, what's the constant, what's the linear, what's everything, or even if identify if it is a constant or not, what we'll have to do is that we'll have to simplify some functions. And so if you have something like this, you're going to have to remember you're going to have to FOIL. First, outer, inner, last. And so that's what you're multiplying. You multiply the first terms, you multiply the inner terms, you multiply the outer terms, and then you multiply the last terms. And this is distributing. And so we would have x times x plus negative 9 times x plus 2 times x minus 9 times 2. Or plus a negative 9 times 2. Then we would simplify x squared minus 7x minus 18. And as we see here, that would be a quadratic function. The first one, that would be our quadratic term, our QT. 7x, or negative 7x would be our linear term. And the last one would be our constant. Okay. And that's what we have. So what you're going to do is you're going to want to make sure you multiply everything through so that you're able to see what the function is. All right, now in a graph of a linear function, or not a linear function, a quadratic function. In a graph of a quadratic function, what you're going to be looking at is you want to be identifying the vertex or the turning point, axis of symmetry, the zeros, corresponding points, etc., etc. And so the bottom image here, this is an example of a quadratic function. And our vertex is the turning point. So where does it, turn back? So as you see here, it's going this direction, and then you see it turns at 0, 0, and then it starts going back up. So our vertex in this one would be at 0, 0. That would be our vertex. Our axis of symmetry will be at the vertex going vertically. So right there along the y-axis. So our axis of symmetry would be x equals 0. Okay, and it divides the parabola in half. So the distance from the axis of symmetry to this point is the same as the axis of symmetry to the one across from it. So those two are the exact same points, or exact same lengths. Okay. Maximum and minimum. So whenever we graph our quadratics, if we have a function that's like f of x is equal to x squared, we're always going to have a minimum or a bottom. So as you see, if you can drop something into it and you hit a bottom, okay, that would be a minimum. Okay, we can hit a low point. Now if it's f of x is equal to negative x squared, we get a maximum, or we have a roof. Okay, it goes up to a certain point, it stops, and then it goes down. Okay, so it hits the top part. So if it's a negative x squared, then it's a maximum. If it's a positive x squared, then it's a minimum. All right. All right. Line of symmetry, vertex, corresponding points. So in this example, our line of symmetry would be at x equals 0. Okay. Our vertex, our turning point, is at 0, 0, as we can identify. And now our corresponding points. So the first one we have is negative 2.5, 6.25. And our corresponding point here would be on the opposite side of it, which would put it right around there. And for this one, what you're going to do is you're going to find the distance between the axis of symmetry and the x value, and then you're going to add that to the axis of symmetry. So 0 minus a negative 2.5 is 2.5, plus 2.5 plus 0 is 2.5. So it would be 2.5, and then the y value doesn't change. For your corresponding points, your y values do not change. They always stay the same. So now the next one, 1.5, and then 2.25. So now if we look at this one, its corresponding point, okay, we would go 0 minus, or the axis of symmetry, minus 1.5. That gets us a negative 1.5. And now we add that to 0, which gets us a negative 1.5. And then the the y value still does not change. So those would be corresponding points, and those would be corresponding points to each other. Okay, and as you see, it's just in this case the y value just doesn't change, or the y value does not change, and the x value just becomes either positive or negative. Not all cases it's like this, but in this case it is. All right, finding a function with 3 points. So this is where you'll use your RREF, your reduced row echelon form, okay, on your calculator. So you'll make a matrix. 3 by 4 matrix, and you'll type in, you'll have these 3 functions. So you'll have a times 2 squared, or the x value, plus b times 2 plus c equals 3. There would be your first one. The next one would be a times 3 squared plus b times 3 plus c is equal to 13, and then a times 4 squared plus b times 4 plus c equals 29. And now your RREF, or your matrix, would be 4, 2, 1, 3, 9, 3, 1, 13, 16, 4, 1, 29. And then you would do your reduced row echelon, and that will tell you your A, B, C. Okay, and then you'll get, so if you were to do your reduced row on this, you would get A is 3, B is negative 5, and C is 1. Okay, and then you would, again, use your calculator to find these numbers, okay, or use substitution or elimination method. Alright, so what you're going to do now for your IRAT is that you're going to look at these two functions and you're going to determine the linear, the quadratic, and the constant terms for each of these. So you're going to have to make sure you multiply these through so you can make to see what the function is, simplify it all the way down. You're going to say the quadratic term is this, the linear term is this, your constant term is this for each of these. And then the second one is you're going to use this graph right here, and you are going to find the vertex, so find the turning point, okay, approximate what it is, and then find the axis of symmetry. Okay, so again, your axis of symmetry is a vertical line, which means your answer is going to be x equals some number. Okay, so that's going to be your IRAT.